Moving on to the next guest speaker for this morning, I'd like to introduce Simon Hall. Simon Hall is the CTO of Payout, part of the Nuvei Group, where he heads up the delivery of payment solutions for marketplaces and platforms. Before Payout, Simon was the chief IT architect at BCJ Platinian, so it's fair to say he has extensive experience when it comes to the actual tech behind payment systems.
I'm very excited to hear about what Simon has to say with someone who's actually been really hands-on, who's moved from the startup environment to this large-scale environment, and to hear how he's working with those payment solutions, because nowadays cash is becoming less and less important, and everyone's just contactless paying for things using those digital tools, especially here where we are in Latvia. Every day, I very rarely carry cash, and sometimes I need it. I'm like, oh, this is unexpected.
Yeah, I don't carry cash at all, so I absolutely agree with you on this. And he has so much experience. It's crazy, from this small startup to like a big scale company, so much adjustment and so much change management. I am very curious to hear from him.
It'd be also really interesting to hear from someone because there's a lot of big vendors out there and they maybe work with legacy systems, they're used to some older systems. So here's someone who's used those startup systems, worked with them, and then gone large scale. The wealth of knowledge there from those two environments is fantastic.
So I guess we'll move. And today, Simon will be explaining how we sleep well at night while shipping financial software daily. Hello, Simon.
Hello, thank you for joining us today.
Hello, good morning.
Fantastic. We've given you a wonderful intro, but it just scratches the surface of what you're going to be talking about today. So crack on ahead. The stage is all yours, and let us know about how you sleep well at night while shipping that financial software daily.
Yeah, great. Thanks for the intro, and good morning, everyone. At least it's morning here in Amsterdam, where I am today. And I'll share a story from the early days of Payouts and how we kind of got to a place where we could ship software daily and actually get some good sleep at night. So hopefully you'll find it interesting. Before I dive into it, I'm Simon Hall. I'm the CTO and board member of Payout. I've been here for about 4.5 years. And in my role as a CTO, I lead our product org, engineering org, and I also oversee our operations, so everything related to payment operations, customer onboarding, etc. Before that, I was working for a consulting company, BCG Platinian. I was working as a chief architect over there, primarily with big organizations, advising CTOs and CIOs on topics on IT architecture, IT organizational topics, etc. But I'm also a big fan of startups, which is also how I eventually found my way to Payout. I still attend a lot of startup events. I love speaking with founders, hearing their ideas, what they're working on. I think that's such an exciting thing to just see and experience. A bit about Payout. So we're based in Amsterdam. We're a fintech or payments company. And what we do is that we make sure that sellers can get paid. And these would be sellers that sell products and services on marketplaces. So a good example of this is a fashion marketplace. So what you often don't see when you go visit these online like fashion places, like Zalando, for example, or Vinkelstraat, which is one of our customers, is that behind the scenes, there are actually many retailers that sell these products. For you, it's just one website, you add these different products, but behind the scenes, these orders can be fulfilled by many different sellers in the back end. So say, for example, you add a beanie, you add a t-shirt, in the end, it comes up to 105 euros. That's what you pay. That's what you see on your bank statement. But behind the scenes, what we do is that we divide that payment into a part for seller A, a part for seller B that sold the long sleeve, and also a part for the marketplace for their commission. In order to do so, we of course need to handle the funds themselves. We can take them, split them, pay them out, but we also need to onboard these sellers, so that know your customer KYC, to make sure that they're not laundering money, etc. So that's just very shortly about what we do. And today I will talk about how we deliver software at Payout. And what I hope that you will leave this presentation with is a bit of inspiration that you can use for your own software delivery process. Get some very tactical tools, not necessarily technical tools only, but really like practices and principles and advice on how you can do it well. And hopefully feel just empowered and encouraged to take this on yourself after this presentation. So with this, this story actually starts in 2021. For those of you who listened to my intro, that's just about 4.5 years ago, when I joined as the new CTO at Payout. And what I quickly noticed is that things were not working very well. Actually, I knew that before I joined, but this was kind of the scene as I was coming into the company. And what was it that was not working well? The biggest issue was that we were not making progress. We were not really meeting our targets. We were not shipping new software. We had a very talented team, but they were just struggling to make progress and to actually do the work that we had promised our upcoming customers that we would do for them. So by the time I joined, the company was about 1.5 years old, and there hadn't been a deployment for 4 months. And if you just take a minute to think about that, like startups need to be fast. There's of course a product that is very young, but nothing had happened for 4 months, or rather, nothing had reached our customers for 4 months. And that's just a death sentence for a company that is this young. And why was this? So the biggest reason why deployments were so infrequent was that past deployments that had been made had led to issues and outages, right? So you worked on something, you shipped it, but then something broke when you actually released it. And of course, having had that experience a few times, the team also got nervous, right? So what if we ship something now? Are we ready for it to break? Like, how can we be sure that it will not break once we actually release this thing? And this feeling only grew the longer we waited, because we kind of started building things. We were not really ready to release it. Maybe we were not sure that it would work 100% when we released it. So we kind of kept waiting and we kept waiting and we kept building. And the longer we were waiting, the more uncomfortable we got, because surely by now we've built up such a big change that something is due to break. And of course, given that we didn't ship the work that we were working on, that also meant that we were falling behind. We had customer waiting, and we had kind of commitments that we had made to them, and we were just increasingly falling behind. So it was quite a dire situation that we're kind of facing when I was first joining the company. So what is the underlying reason why it was so difficult for us to ship at this point in time? So splitting it up in 3 parts. So the first kind of issue that we had was that the foundations that we had to actually deliver software was very poor. A good example of this is that our environments that we had were misaligned. They were all different. So the way to think about it, we had 3 environments. We had our development environment, which was really the laptops of our developers. We had 1 shared staging environment, and we had 1 production environment. But these environments were all different. For example, on our staging environment and our production environment, had different data schemas on our databases. They had different infrastructure setups. And this just meant that there was no way to test the software that we were developing in a production-like environment. We also had more issues with our infrastructure. For example, it was very difficult to find and debug issues. At that point, our production environment was 5 servers that we had rented on a private cloud environment, but we had no way of actually working with these servers beyond logging into them over SSH. So if there was an issue, we had to log into each one of these servers. We had to get the log files as a zip, download it, and do some kind of text search on our own laptops, which was, of course, very time-consuming and just ineffective. And we also didn't have a way to standardize our build and deploy process. So the build at that point was done on the local developer laptops, which again were different to the production environments that we had. These binaries that were built, they were uploaded to the servers. They were uploaded over SSH, and then the application itself was restarted. And this whole process was documented in a Notion page. So yeah, it's really people over systems that was making this work at this time. And of course, we also didn't have a lot of tests. There were a few unit tests in the code, but there was nothing really to make sure that our software worked end to end. And the few tests that we had were run on a best effort basis. So really, it was part of the deployment guide to make sure that you run all the unit tests before you deploy. But of course, this was not always done, and it was very error prone at the time. So it was bad. And of course, we had set up the system in such a way that we were not having any visibility or very limited visibility on what we were shipping. And we were pretty much just hoping that we wouldn't get ourselves into an accident or with an issue with our production systems. So how did we go about fixing this? Of course, we started with a lot of room to improve things. And the first thing that we did was to start up with our infrastructure foundation. So we set ourselves up on Google Cloud, and this was a very quick setup process. Really, it was getting the company credit card. It was signing up through the self-service on GCP. And we started putting together a basic infrastructure setup. We set ourselves up on Kubernetes. But the most important thing that we did was that we scripted this infrastructure configuration. So we used the Terraform, which is an infrastructure as code toolkit that you can use. And really what it gives you is the ability to specify in code that is managed in a source code environment, saying, this is exactly how the infrastructure should look like. I need this Kubernetes environment with this networking, with these users and access rights. So really everything is described in code. And what that also means is that you can use the same code base, the same recipe for the infrastructure, and make sure that all your environments are exactly the same, right? And setting ourselves up on Google Cloud also gave us the foundation for automated deployments, given that we had our Kubernetes environment, and we also set up these deployment scripts that could also be managed in source code and make sure that once we deployed a new piece of software, we always did it in the same way as was defined in the scripts and not necessarily relying on people logging into servers and uploading binaries, all of that stuff. Another important change that we made was that we aligned our data models across the environments. So instead of managing the database schemas by hand, as we had done before, we now did it as part of the source code. So there are these tools that you can use to effectively have incremental SQL updates to the schemas, and you just manage that as part of the source code. And when you do it that way, you make sure that all your environments are aligned. So your development environment, your staging environment, your production environment, they all are the same because they all use the same source code, and the source code and the database schemas are always in sync by default. And also moving everything to GCP also gave us access to these tools that GCP offers out of box, like the logging and monitoring most prominently. So this was really the first thing that we did when we got started 4.5 years ago. And what we also did with this infrastructure foundation in place is that we started standardizing our build and deployment process, so our CI/CD process. Very similar to the Google Cloud experience, we signed up for a cheap account with GitLab to host our first pipelines. So all of the source code went on GitLab, all of the pipelines went on GitLab. And from there, we started building with a standardized build process. So every time you checked in a piece of code, there's an artifact that is produced. This artifact is what we then use to deploy later on. So It's not rocket science, but having this standardized and unified also really gave us the foundation to do all of the quality things that we wanted to do later on. With these pipelines, we also started running the few tests that we had as a part of the build process. So moving from using a Notion page as a guide to run these tests, we just put it in the pipeline and it's always run. And also with our deployments, given that we have our builds, we have our artifacts being generated, we have our tests being run, we also had our deployments running from these pipelines. So no more logging in, but really a button or an automated deployment to these environments. So this is really basic. Of course, this is the foundations that we needed to start delivering again, moving from using people and best efforts to systems and processes that are repeatable. We started getting this more under control, and it really set ourselves up to also make this faster and more resilient. So the real tool that we used to improve on this was test automation. And I think this is where I want to spend a little bit more time on. And one of the early things that we did as well was to put in place a regression test framework. So what's the difference between a regression testing framework and a unit testing framework? Maybe just in a nutshell, a unit test tests a small piece of code often, while a regression test is focused primarily on testing the functionality. So we started creating tests in the given, when, then style test or Gherkin tests. And our first starting point was to cover the core workflows in these styles of tests. So for us, this is a new payment, there's a payout, there's an onboarding of a new seller. And we really focused on testing these functionality end to end when we got started, in the most basic way. All right, so can I make a payment? Can I onboard a new seller? Can I make a payout? Of course, there were a few more workflows than that. And we tested it in a way that is also simulates how our customers would actually use this. And this test framework was set up to run on both local and shared environments. So on our local environments, we had exactly the same tests. We mimicked our infrastructure setup or application setup on our local environments with test containers. And in our shared environments, we had production-like infrastructure. So we tested it against live environments so that it would be representative of how it would actually run once the code and the binaries reach production in the end. We also made sure to run this test suite every night and also before any deployments. Right, so the test suite itself takes a little bit longer, which is also why you don't necessarily want to do it on each code change. But at least you run it before you deploy. And the practice that we put in place is, as soon as there's any issues detected, we just block any deployments, right? So the tests are always needs to pass before we release any code. And for the nightly tests, as well as the before deployment tests, we always share the results with the full development team. So everyone is aware of how our application is performing. And if there are broken tests, everyone is aware, and it's kind of a priority to fix this before we can proceed. So that's the journey that we went on. We put in place a first handful of tests. I think it was around 10 to cover these absolutely core functionalities. And now over the years, we built up to a library of around 400 end-to-end tests that covers pretty much anything that you can do on our platform. And this is how it looks like. This is just an extract from one of these emails that are going out. I had to go some days back to find one with some broken tests. But really, it's nothing necessarily very special. I'm sure you have seen test suites like this before. But it runs the whole battery of tests. And then if there are any tests that are failed, you can also then follow to see, what was it that failed? like which test failed, for what reason, what did we expect, and this is then the starting point to figure out, why did this test fail in the first place. Great. Then finally, how do we make this work? Like, why is this successful? And I think this is the main learning from this presentation. It's not a super advanced testing framework. This is not, but what it is, it's simple, it's understandable, and everyone kind of can contribute to these tests. They understand how they're being run, and they understand if they fail, like what test has failed and for what reason. So it's kind of simplicity works really well for us. We also have built a culture around paying attention to these failed tests. So as soon as something breaks, we all pay attention to these failing tests and we make sure to fix them before we proceed with other work. And I think I've seen many test suites through my days, and I think this is then probably the most common issue that I see, that you create some tests, over time they are flaky, they break, you don't maintain them, or you don't pay attention to the results, and then in the end they're useless, right? Because you don't know, do they fail because of a valid reason, or is it something that has truly broken that needs attention? So this is a culture that we've built where we always stay up to date and alert with any broken tests. The whole team is involved. This was a very conscious choice that we made, that it's not a single person's responsibility to be the test engineer or to pay attention to this, but this is really something that involves the whole team. They're invested in both fixing the tests, but they're also invested in making sure that we have good test coverage. So it's not it's really a team effort, and that also takes this responsibility and this ownership, not only for the code that they write, but how this code is then kind of performing in production once we release it. We also make sure that any new functionality we develop have tests from day one. It's just part of our development process. And if you try to ship new functionality without tests, you will get feedback from your fellow engineers that this is something that we need to do before we can complete the work. And if something happens, we shipped a piece of code, and months later, we see that there's an edge case that we ran into that we didn't cover in our test suite. We also, as a part of our incident resolution process, we always develop new tests to prevent this from happening in the future. So with this, what are the kind of results that we have achieved over the years? So first of all, the deployments are no longer stressful. We deliver and we ship code almost every day. And with that, we're also making progress quickly. And what we see is that we can rely on this testing approach and this test suite to cover all of our quality needs. So we don't have a quality assurance team. We don't have a manual tester, but really we put our faith into this, and this kind of testing approach is what we rely on. And this just means that you work on something, you finish a piece of code. If it's already covered by test cases, you can just ship it directly. Of course, you will do like a 4-eye review on the source code itself, but there's no guiding a quality engineer, waiting for QA to approve it. There's no weekly release where we test everything, but we can really take something from start to end very quickly. And we can do so given that we've built up this muscle of test automation over the years. And that just makes us super quick, I think, especially in financial services. It's hard to ship software quickly, but this approach built up over the year has just served us very well. And it's one of our biggest strengths that we have within the company today. So as you probably noticed, I've signed up with my Payout name. I'm the CTO of Payout, but it's now a Nuvei company. And the reason for that is that we were acquired last October. And Payout, this Amsterdam-based startup, was acquired by Nuvei, which is a multinational payments company. And one of the key reasons for this acquisition was the product development team was highlighted as a strength in the product that we've built. And my strong conviction is that the reason why we can be strong as a product development team is that we've built up this muscle of test automation and shipping fast and having a DevOps mindset to what we do. And just a few learnings that I've taken from this work in the past. The first is try to move away from best effort individual tasks. It's just bound to break. Even if people are really doing their best, there's just so much room for manual errors. And instead, the main goal for software delivery should be to make it standardized. The standardized infrastructure, standardized building, standardized testing. The more you can standardize and script and make repeatable, the better your life will be and the faster the team will deliver. And again, you should let your tools and automations drive, not people and manuals. People are just bound to make mistakes, but your scripts will always do the same thing. And it's better to invest the effort in repeatable scripted processes rather than fine-tuning the language in the manuals or having, conversations with a colleague that made a mistake at some point. So, and for the testing, and this is maybe more of a personal belief, I expect that people have different opinions on this, but the best kind of testing is testing that tests real functionality end to end. Of course, unit tests, they have their place. I'm not suggesting that you should skip them, but really where most of the issues arrive is when kind of components and functionality interact together and come up with unexpected results or breaking points between them. And I think where we have gotten most value from our testing is in these end-to-end tests. And that's what I would focus on to develop as well. And this kind of testing can also be very simple, as I've illustrated in the Payout story. We started with just a handful of tests. And as long as you have the foundations of the way of working, you can just start with a handful of tests and then just put in place the practices to increase this test coverage as you go. And yeah, this also maybe goes without saying, but tests are only useful if you actually use them, all right? So you need to pay attention to the results. You need to make the outcome of these tests and any broken test the priority of the whole team. And otherwise, it's just busy work to create tests that no one is paying attention to. And yeah, make it a priority of your whole team. I mean, at the end of the day, the DevOps mindset is that you ship a product as a team. That includes all of the engineers, everyone involved in testing. It includes product, it includes infrastructure. And at the end of the day, your goal is to ship the best product as quickly as possible. And with that, it's also a priority for everyone that the product is functioning as it should, and that you have control over the quality of the software that you ship. So that's it. I have a few more minutes to spare, so happy to take any questions if there are.
Yes, Simon, thank you. Thank you so much for being with us today. Thank you for your presentation. And wow, what a journey. I mean, starting from a young startup with 4 months without a deployment to now being a part of Nuvei Group, you definitely seen it all. And yes, we do have a couple of questions to you, and I will dive right in. And the first one being, if you were starting over today with all the knowledge you acquired during your experience, what would you do differently?
Yeah, I think on that topic of test automation and the kind of software delivery. We've made many mistakes at my time at Payouts, but I think this part we got right. I don't know if I would make any big changes to the approach that we took. I think we took a really simple, practical approach with simple tools, inexpensive tools, simple frameworks, few simple tests that covered a lot. And I think that approach was really successful for us. And I would probably repeat that again. Many other mistakes that I would wish to undo, but not this one.
That's good. Thank you. I did also have a question of, you advise start simple, but how simple is too simple? Where do you draw the line on that?
I think it needs to be meaningful. So of course you can make like 5 unit tests for some random functions in your code base. But at the end of the day, they're not going to give you any value. I think that the simplest I would start with when it comes to test automation specifically are a few end-to-end tests that covers like real functionality on your platform.
Thank you.
I do have one more question, and because you're emphasizing in your presentation the role of the team in all the process, so I would like to know what was the most surprising thing you learned about your team through this transformation?
Yeah, I think that the biggest learning was just how invested the team is in also making this work. I've seen many companies, especially through my consulting days in the past, where testing is someone's responsibility, and the developers with the engineers, they just focus on writing code, but it's got two separate worlds with two separate priorities. But what I was surprised with to see at Payout is just how invested the team is to also build good software and to keep this up to date. Of course, it's now me talking about the work that we've done with this test suite. It's amazing, but the truth is that so much of this work has been done by the engineering team themselves, and they are really the champions of this work. And that was surprising in a very positive way for me.
We have one question from the audience that I did want to pose to you because we're running out of time, but very succinctly in a way. What are some of the common bugs you're starting to see more recently as the financial sort of payment system and the landscape changes? What is some bug you're seeing pop up every now and then?
Yeah, so we're now in the process of expanding to more regions, and we're still using a single code base to serve our regions, and we're now starting to run into just regional differences. And kind of assumptions that we've made on how things should work. I mean, being a European company, now expanding this to more regions. So I think that's top of mind when it comes to quality for me at the moment.
Fantastic. I also have a comment from the audience I'd like to share with you. It takes real professionals and leadership to admit mistakes that you made along the way when implementing good quality solutions and improvements. Some great points and a very insightful presentation. So
Great.
you have a fan
Thank
in
you.
the audience, a big fan in the audience.
Excellent. Appreciate that.
With that is all the time, and we won't keep you any longer, but we will be seeing you later today. So remember Simon's face because you will be seeing more of him. But for now, thank you for your time. We'll see you again later, and have a great day.
Great. Thank you very much, and
Thank
have
you.
a great day.
Thank you,
All right.
Simon. Bye.
Bye-bye.